In this project, we looked at Amazon review sentiment analysis. We'll be covering, you can go to the next slide. We'll be covering our problem statement, the data exploration that we did, the Roberta model, linear regression model, as well as the sequential model. So our key challenge was to correctly identify the opinions expressed in Amazon customer reviews, and the goal is to accurately classify the sentiment of those reviews. The subtleties of human language, such as idioms, irony, and different ways of expressing feeling, make categorization more difficult to understand. Additionally, there's a large imbalance in this data set. There's a higher number of positive reviews, which might skew the research and reduce the prediction model's accuracy. The inputs for this project include Amazon review, the words written by the user, and the outputs include the sentiment of each review, which is categorized as positive, negative, or neutral. So as mentioned, sentiment analysis involves categorizing opinions expressed in text as positive, negative, or neutral. This problem is crucial for businesses to gauge customer sentiment towards their offerings and products. Amazon, being a major e-commerce platform, can greatly benefit from sentiment analysis for several reasons, including improving its products and services by identifying areas for improvement, as well as addressing customer concerns and refining the product accordingly. Here we take a look at our data set. So we ended up using 5,000 of the over 500,000 reviews that the data set initially offered. Some of the tools we used include Python, Pandas, TensorFlow, Hugging Face transformers, as well as Keras. Looking at the data set, we can see that we have access to the actual text that the user provided, the review, as well as a score given by the user, 1 through 5. All of this was given or presented in a CSV format. We did quite a bit of data pre-processing to get the data ready for use, which included cleaning. So we lowercased all of the text, we removed punctuation and stop words. We also implemented tokenization. As for feature engineering, we created sentiment and review length columns. We did quite a bit of EDA and visualization, including the distribution of ratings and looking at the most common words in positive and negative reviews. So here we have a graph of the reviews and the ratings given by the users. We can see that there's clearly a significant bias towards positive reviews, which is shown by the 5, the highest rating that could be given. We have a little uptick in number 1-star reviews as well that we can see. Next, we have the Roberta model. So the Roberta, or the Robustly Optimized BERT approach, stands as a significant advancement in natural language processing. It offers a versatile and powerful tool for various text understanding tasks. It's actually built upon the BERT, or the bidirectional encoder representations from Transformers architecture, but the Roberta model benefits from extensive pre-training on large-scale text corpora, which enables it to learn rich representations of language. So overall, the Roberta model provides a deeper understanding of contextual relationships within text and allows it to capture nuanced meanings and semantic intricacies. So here we have the results of the Roberta model that we obtained. We can see that the model performs very well in terms of accuracy, precision, recall, and F1, which suggests that it's a very robust model for sentiment analysis. However, we can see that the scatter plot on the left displays that the sentiment and the review length are not strongly correlated. Furthermore, the histogram on the right shows that the model is more likely to assign a sentiment score at extremes, either very high or very low. And this could be due to the nature of the text itself of the reviews, or it could be due to the model's confidence in its predictions.
Okay, thank you, Kat, for going over the first half of this project. My objective now is to discuss the linear regression model followed by the sequential model. First, I want to talk a little bit about the runtime and what we utilize. So we collaborated on this project using Google Colab's CPU. And this project should finish in about 20 minutes. And we also use Kaggle, which the project will finish in about 12 minutes. I also want to reiterate that the full data set is about 500,000 rows, and we opted to conduct this project with only the first 5,000 rows. So we started with the linear regression model really just because it's quick and simple, and we wanted to check the hypothesis noted here, which is, do longer review lengths indicate a lower sentiment score? Going over to the results, we see that most of the values are clustered at the top or the bottom of the sentiment axis, suggesting that reviews are mostly classified into either a positive or negative sentiment without much in the middle. The red line represents the predictive values from the linear regression model, and you can see the negative slope of the line suggests that as the review length increases, the model is worse at predicting sentiment scores. Therefore, we concluded that we reject our null hypothesis and that the review length is not a good measure for predicting sentiment score. And also, going off of the low R2 squared score and the mean squared error. Next, we'll dive into the sequential model. So as you can see, there's a brief definition of what the sequential model is. And the first steps we did before we even got to building the sequential model, there was some pre-processing that was done, which involved tokenizing the text data. This was done with the help of a cleaning function that we defined even before we did the linear regression model. So we vectorized the clean text column, which created a matrix for input features. Then we extracted the target variable, which was the values of the binary sentiment column. Next, we did a train validation test split of the data, followed by padding each sequence to make sure that they were all reading at the same length. Next, we initialized our sequential model. Then we added 3 layers. So the first was the embedding layer, followed by the LSTM layer, followed by the dense layer with a ReLU activation. And for the dense layer, we used binary classification. So a number 1 on the dense layer. And once we defined the model, we compiled it with an optimizer, and there were many different combinations of activators and optimizers that we utilized. And I'll just name a few of them. A few combinations were the Swish and RMS prop optimizer, followed by the Swish with the Atom optimizer, and also the ALU activator with the NATM optimizer. And keep in mind, all these perform very well, above 95% accuracy, but in the end, we chose to utilize the ReLU activator with the Atom optimizer. And for compiling, we used the binary cross entropy. And looking at the results, so the results of the sequential model, we saw that we were getting 99% accuracy. However, the model was not generalizing well to the validation data. So the result is that the model was overfitting. And that was indicated by the increase of validation loss with a stagnation on validation accuracy for each epoch. So the model was learning specifics of the training data rather than the underlying pattern to apply that to the new unseen data. So we attempted to improve the sequential model by making some adjustments. Let me go back one slide. So the adjustments that we made was that we increased the LSTM complexity. We added a dropout. We used a global max pool 1D. And then lastly, we implemented early stopping. So after these adjustments were made, we noticed the accuracy was near 100%. However, the validation accuracy seems to stall at 82 to 83%. And the best generalization occurred at the first epoch. So we can conclude once again that the model was still overfitting. And just a note on that is that these adjustments have not been made on the full data set, only the first 5,000 rows. So that would be the next steps in future analysis. And we would also attempt to get a more balanced data set in the future by either removing positive reviews or by implementing a technique called SMOTE, which creates synthetic samples of the minority classes. Overall, I'm happy with the model's performance and look forward to conducting more sentiment analysis on other data sets. And I will pass it back to Kat so she can read the first question on our Q&A section.
All right, so question number 1. What is the significance of sentiment analysis in the context of Amazon reviews? So, sentiment analysis on Amazon reviews is crucial for businesses as it helps gauge customer sentiment towards their products and services. This analysis allows Amazon to identify areas for improvement, address customer concerns, and refine their offerings accordingly.
Okay, thank you. I will read question number 2. Can you explain the input and output representations used by the deep learning model for sentiment analysis in the study? Answer. The deep learning model used in the study takes Amazon reviews as input and predicts sentiment as output, meaning negative, positive, or neutral.
And question number 3. What challenges were encountered in our sentiment analysis project and how did we address them? So we encountered data skewness, more positive reviews, potentially leading to model bias and overfitting of the sequential model. We addressed this by implementing dropout, early stopping techniques, and exploring sophisticated regularization strategies to try and refine the model's training process and improve its ability to generalize. So next we have our references that you can feel free to look at. And just to conclude, our studies provided a detailed examination of Amazon sentiment reviews through advanced deep learning techniques. We demonstrated the value of natural language processing in improving customer service despite challenges like data imbalance and model overfitting. Overall, it underscores deep learning's role in transforming customer feedback into a business asset, suggesting further enhancement of model accuracy and offering insights for future innovation. Thank you for watching.
Thank you all for joining us.